Hi, I'm Jackson Joel, a final year CSE student and a Supabase-based backend developer at Archery Technocrats. And I want to talk about something nobody mentions when they talk about building with AI. Anyone can build a website today. Anyone can ship an app in a weekend. AI makes the starting part easy, but here's what AI doesn't fix: the part after. The bugs, the errors you can't explain, the stack traces that make no sense at 2 a.m., the teammate who has no idea what you already tried, the fix that worked last month that you can't remember. Building something is easy. Making it actually work and keeping it working, that's the hard part. That's the problem DevTrace AI solves. Your team's permanent debugging memory, powered by PowerSync, Supabase, and Mastra AI, that works even when the internet doesn't. Let me show you. Before we dive in, let me show you how DevTrace AI knows who you are. Every account connects to GitHub, one click, and your identity is linked across the entire app. Your sessions, your projects, your debugging history, all tied to you. You can also set a profile photo, which shows up in live collaboration so your teammates know exactly who's active in a session with them. Supabase handles all of this: email and password, GitHub OAuth, Google OAuth, and profile photos are stored directly in Supabase bucket storage, so nothing lives on a third-party server. Now back to the dashboard. This is your home base. Everything in one place: your projects, your recent sessions, your errors, your resolution rate. The dashboard gives you a complete picture of your debugging activity the moment you log in. This is where every debugging journey starts. Here's my project. I've got 3 open bugs, all real errors I hit while building DevTrace AI itself. I'll open this one. When I hit Analyze Bug, this doesn't go to some generic chatbot. The request hits a Supabase edge function. The Groq API key lives there, in Supabase secrets, never in the browser. The edge function verifies my JWT first, then calls Groq with Llama 3.370b server-side, and streams back a full structured breakdown. 8 tabs. Overview with root cause and confidence score. 3 fix options: quick patch, proper fix, workaround, each with full code, a visual crash timeline, a shared checklist, follow-up chat, auto-generated test cases, log analysis, and an architecture review. This entire analysis is saved permanently as JSONB in Supabase. It doesn't disappear when I close the tab. It's there tomorrow, next week, 6 months from now. Searchable, shareable, and synced to every device via PowerSync. But if I want to go even deeper, there's Mastra. I click Run Deep Analysis. This hits another Supabase edge function, JWT verified before it ever touches the Mastra API key. The request routes to the session debugger agent on Mastra Cloud. This agent doesn't just explain the error, it finds the exact broken line and gives me a diff format fix. Before and after, side by side. It tells me why this pattern happens specifically in my stack. It flags risks that might surface after I apply the fix. And it gives me verification steps to confirm it actually worked. This is the difference between an AI that responds and an AI that reasons. Standard analysis tells you what's wrong. Mastra tells you exactly where, exactly why, and exactly what to do, with proof. Now let me show you something most apps can't do. I'm going offline, right now, from DevTools. The app doesn't crash, doesn't freeze. The orange banner tells me I'm offline, and that's it. Everything still works. I'll create a dummy project, add a debug session inside it. Done. See that bell? I click it. There's my queued record, sitting in local SQLite, waiting to upload. PowerSync wrote it locally the moment I hit save. No network needed. Now I go back online, and it's gone, flushed to Supabase automatically. No extra code, no retry logic, no manual sync. PowerSync handles the entire mutation queue the moment the connection returns. That's local first. Writes never fail. Data never disappears. Back to my main project. I'm offline again. I'll log a fourth error, similar to one I've already debugged before. The moment it's saved, two things happen instantly. No network, no API call, everything runs on device. First, similar sessions. When I originally logged those three errors, transformers.js generated a 384 dimension semantic embedding for each one, right here in the browser. Those embeddings are stored in local SQLite via PowerSync. The moment I log this new error, cosine similarity and keyword scoring run against my entire local history simultaneously. And it surfaces the matching session with a confidence score. It didn't match on exact words, it matched on meaning. Second, offline memory assist. Since I'm offline and this session has no prior AI analysis, DevTrace AI doesn't show a spinner. It queries my local SQLite, scores the top matching sessions, extracts root causes, past fixes, checklist items, and synthesizes them into actionable guidance. Clearly labeled as offline synthesis, not fresh AI. Confidence level shown. Evidence linked back to the exact sessions it pulled from. No internet. No server. Full debugging intelligence from your own history. This is Debug DNA, your personal debugging fingerprint. I hit generate. This fires a Supabase edge function with service role, meaning it queries your entire session history directly in Postgres server side, not through the app, not through PowerSync. SQL aggregations run across every bug you've ever logged, error categories, resolution rates, time patterns, what you fix fast, what beats you. That raw data goes straight to Groq, which writes a personalized narrative, not a generic summary, a fingerprint. Specific to your history, your patterns, your weaknesses. Look at this. Category breakdown, which error types I crush, which ones I keep hitting. Weekly activity chart, how many sessions I logged each week. And the narrative, Groq's honest take on what kind of developer my debugging history says I am. This is the only tool that doesn't just help you fix today's bug. It tells you what kind of bugs you'll write tomorrow. This is the sync status page, and this one's specifically for PowerSync judges. I'm offline right now. Every table you see here is PowerSync's local SQLite, 11 tables, live row counts, all reading from on-device storage. No network needed to render any of this. See the upload queue. Those are mutations sitting locally, waiting to flush. Every write that happened offline is accounted for, nothing lost. Now back online. Watch the queue clear. PowerSync flushes every queued mutation to Supabase automatically. WAL replication picks it up and syncs the delta back down. This page exists because in a local first app, trust matters. You shouldn't have to guess whether your data synced. Sync status makes the invisible visible. Your entire PowerSync layer live in one place. Two more pages worth seeing. AI Insights is your AI record book. Every analysis DevTrace AI has ever run for you. Confidence scores, common error categories, recurring patterns, what the AI flagged most. This isn't generated fresh every time you open it. It's pulled straight from your local SQLite, all that JSON-B analysis data that was saved permanently when Groq ran each session. Zero network, instant load. Then analytics, a visual timeline of your entire debugging history. Bugs logged, bugs resolved, resolution rates over time. All charted from your local database. No dashboard call, no API. Just your data, rendered instantly from PowerSync's local SQLite. Together, these 2 pages answer a question most developers never think to ask. Not just, how do I fix this bug? But, what kind of bugs am I actually writing? And am I getting better? Now, let me show you something that took the most engineering to get right, and requires zero custom backend to work. On the left is my main account. On the right is a second account. I'm going to invite them to my project right now. The invite goes through the shares table in Supabase, a single row with the resource ID, resource type, and invitee. That's it. The moment it's written, PowerSync's sync rules pick it up. The shared project appears on the right. No page refresh, no email link, no manual accept. Both accounts are now inside the same project. Look at the project header, avatar stack, live.pulsing. That's project level presence. Each account wrote a presence row to project_presence via PowerSync on open. The heartbeat updates every 30 seconds. No WebSocket, no Supabase real-time subscription, no polling. Just PowerSync streaming WAL changes to local SQLite on both devices simultaneously. Now the activity feed. Every action I take, creating a session, resolving a bug, running AI analysis, gets automatically logged to project_activity by use sessions. My teammate sees it the moment it happens. Clickable, navigable, live. Now we're both inside the same session. I'll send a message. The message hits local SQLite via PowerSync.execute on the left, instantly visible on the left. PowerSync queues the upload, flushes to Supabase. WAL replication streams the delta down to the right's local SQLite. Under 2 seconds, end to end. No WebSocket server, no Express backend, no Supabase real-time. Just PowerSync, doing in 3 lines of SQL what usually takes a full backend to build. One more thing about sharing, it's granular. I just gave my teammate access to the whole project, but I can also share a single debug session, nothing else. They see that one session, that one error, that one AI analysis, not the project, not the other sessions. The same shares table, same PowerSync sync rules, just a different resource type. Project access or session access. Your call. Now, the project analyzer. This is the second Mastra agent. Where the session debugger goes deep on one error, the project analyzer zooms out across every debug session under this project. I hit Run Analysis. This routes through the same JWT verified Supabase Edge function to Mastra Cloud. The agent receives all session data, error messages, severities, resolution statuses, AI analyses, and reasons across all of it simultaneously. Look at what comes back. A health verdict for the entire project. Recurring error patterns with frequency counts. Which bugs keep showing up and why. Systemic architectural issues the agent detected across multiple sessions. And prioritized recommendations. What to fix immediately, what to address short term, what to plan for long term. This isn't a summary. This is a technical audit of your project's debugging history, generated in seconds by an agent that actually understands your stack. Let me show you what's actually running behind DevTrace AI. The front end is React, Vite, and TypeScript. Fast, type-safe, production-ready, deployed on Vercel. PowerSync is the offline and sync layer. You can see the dashboard here. 11 tables replicated via WAL, 5 sync bucket definitions, local SQLite on every device. Every read in the app comes from here. 0 network latency. Mastra Cloud hosts the 2 AI agents, Session Debugger and Project Analyzer, both called through a JWT verified Supabase Edge function. The Mastra API key never leaves the server, and Supabase is the backbone, Postgres with RLS on all 11 tables, 3 auth providers, bucket storage for profile photos, and 3 edge functions handling all AI calls, rate limiting, and agent proxying server-side. 4 layers, each one doing exactly one job. Nothing unnecessary, nothing exposed. DevTrace AI is fully open source. Every line of code is on GitHub, free to fork, explore, and build on. This was built solo, from scratch, for the PowerSync AI Hackathon 2026. Every feature you saw, offline first sync, hybrid RAG, Mastra agents, live collaboration, all of it is live right now at dev-trace-ai.vercel.app. Debugging is something every developer does every single day. DevTrace AI makes sure that time actually compounds. Every bug you fix makes you better at the next one. Thank you for watching. I hope DevTrace AI earns a place on your list.